Okay, this problem shows the base of an object, and they want us to find the volume of this object given cross sections which are perpendicular to the base are equilateral triangles. I've already done a couple videos where the cross sections were squares and the cross sections were semicircles. This time they're equilateral triangles. So what does that mean? Think of it, this is the base of an object. It's coming out at you, and what's coming out at you? Equilateral triangles are coming out at you, coming out at you, coming out at you, like that, right? So we have to find the volume of these bunch of equilateral triangles going across as we go from left to right. So what do we got to do? We got to do this thing in two parts because from here to here it looks like one shape. From here to here the base is another shape. So let's do it in two parts and then we'll add the two volumes. That's all we're going to do. So the first part, what's it look like? It goes like this, right? It goes from 3 to -3 there, and it goes from 0 to 1 here. Okay, so let's find, I think the first thing we got to do is find, so remember there's these triangles coming out at you. So if we can find this distance from here to here in terms of x, that'll give you the side of one of your equilateral triangles, which I think would be good, right? So we have to figure out the equations of these lines. Let's see. Y equals mx plus b, right? Well, b is 0. B is the y-intercept. That's 0 for both of the lines. So what's the slope? Change in y over change in x. So change in y for this top guy is 3. Change in x is 1. So y equals, it's 3x, right? Change in y over is 3, over change in x is 1. So this one is y equals -3x. So if we want to find the distance, the side of one of the triangles in terms of x, we would just do top minus bottom, right? So it's 3x minus some minus 3x equals 6x. Okay, so that's the length of one triangle. So you have these equilateral triangles, cross sections that all look like this. Okay, what we want to do is we want to use integration to integrate the area of these equilateral triangles. So we got to figure out the area of this triangle. So who remembers the area of a triangle? Area of a triangle is equal to 1/2 base times the height. So we know the base is 6x, but we don't know this is the height, right? We got to solve for the height. How are we going to do that? Well, think of it this way, guys. This is 6x here. This is half of the 6x. That's 3x, and this is the height, right? We want to figure out the height. So can we use the old Pythagorean theorem? I think so, right? We can use the Pythagorean theorem. So it's 3x squared plus h squared equals 6x squared. Right? Did I do that right? I think I did. All right, so what do we get? We get square root of 3, square root of the x, 36x squared. Right? Okay, subtract 9x squared from both sides, 27x squared. So what's h equal to? Plus or minus the square root of, what's square root of 27 is 3 square root of 3, right? Square root of 9 times square root of 3, so square root of 9 becomes a 3x, right? Oh, so we just got the height. So 1/2 base height, so our area for a triangle then, 1/2 base height, which is equal to 1/2. The base is 6x, and the height is plus or minus, so we don't have to worry the minus, right? Right, okay. So that's our formula for area. So if I simplify that, I get 3 times 3, I get 9 square root of 3 x squared. Whoa. All that to find that area of the triangle. So for this first part, the volume is equal to, okay, what's x going from 0 to 1? What's the area of the triangle? 9 square root of 3x squared dx. Right? So I move the 9 square root of 3 out front. So I have to do the antiderivative of x squared. So it's 1/3 x cubed between 1 and 0. Okay. So if I plug a 1 in, the 9 and the 3 cancel out. The 3 cancels out with a 9. So you end up getting 3 square root of 3 times 1 cubed minus 0. So this is the volume for the first part. Okay. How about the second part? By second part, I mean this thing. This part. It looks actually, oh, it's okay. I got it okay. So we know that we have equilateral triangles that come out at you. So from here to here, it's 6, right? So we have these equilateral, because it's 3 to minus 3. So we have these equilateral triangles. Whoops. Before we had 6x, this time we just have 6 on all sides. So the h is down there. We have to find the h, so the triangle, you can look at it like this. It's 3, 6, h, because from here to here is half the 6. So what do we get? Pythagorean theorem. Right? So we end up getting h squared is equal to 36 minus 9, right? 36 minus 9. So we end up getting h squared is equal to 27. So h is equal to plus or minus the square root of 27, which is, we don't have to worry about the minus because we know it's on a minus height. So that's what our h is. Okay, so now we got to do our value for this second part. So what does x go from? X goes from 1 to 2. 1/2, what's the base? 6, what's the height? 3 square root of 3 dx. Hopefully I did that right. Okay. So let's see, can we simplify this? I think it's 9 from 1 to 2 of 9 square root of 3 dx. Okay. So let's see. So we take the antiderivative, so that's 9 square root of 3 times 1/2. No, just times x, right? Times x between 2 and 1. Okay? So you get 18 square root of 3 minus 9 square root of 3 when I plug the 2 and the 1 in for x. So you end up getting 9 square root of 3. So I'm going to put a box around that, because why am I putting the boxes around it? Because now we have to add those two together, right? Because that gave you the volume of the left part, this gives you the volume of the right part. So the total volume equals 3 square root of 3 plus 9 square root. Running out of space, you guys. 3 is equal to 12 square root of 3. That's the total volume. So hopefully you guys could see my whole whiteboard. Sometimes I have that issue. No, I think you can. So there's a lot of work there. But what we had to do was divide this thing up into two parts. We know they're equilateral triangles. We had to find the area of a triangle. We had to do 1/2 base height. So we had to use the Pythagorean theorem for both parts. And then we had to find the volumes by integrating. And then remember, the last step is to add the two pieces up. Whew. Okay, I'm tired. I wonder if you are. Okay, thanks. See ya.